Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2118 indicates a problem with the throttle actuator's current range or performance in Honda Civic models from 2006 to 2011. This error often signals concerns with the electronic throttle control system, which plays a vital role in managing engine performance based on driver acceleration input. The throttle actuator is responsible for adjusting the airflow into the engine by controlling the throttle plate, and it is located near the engine intake manifold. Identifying and resolving issues related to this DTC is critical for maintaining optimal engine performance and ensuring a smooth driving experience. In this presentation, we will delve into the detailed diagnostic process, covering the potential causes and step-by-step troubleshooting steps, which will equip you with the necessary methods to diagnose and fix the issue efficiently. The error P2118 relates to the throttle actuator's control unit, which is influenced by the engine control module, ECM. The ECM processes accelerator pedal positions and regulates the throttle plate accordingly to optimize engine air intake and fuel efficiency. This process is critical for responsiveness and fuel economy in the Civic model. The throttle actuator is located near the engine's intake manifold, allowing it to effectively control the airflow into the engine. The performance of this actuator is monitored by the ECM, which can detect real-time adjustments and adapt to driving conditions. If the ECM identifies inconsistencies in the actuator's performance, it triggers the P2118 code to provide a warning that requires further diagnostic scrutiny. Several potential causes can lead to the P2118 code being triggered. One primary culprit can be poor electrical connections at the throttle body or ECM, which can result in insufficient voltage or signals being sent between components. Additionally, a faulty throttle actuator can also cause performance issues, failing to respond adequately to commands from the ECM. Wiring issues such as shorts or breaks in the harness, particularly between the ECM and throttle actuator, may lead to intermittent signals causing the error code to be logged. Finally, issues related to grounding can also be significant in these failures, as poor grounding can result in erratic behavior of the throttle control system, further complicating the diagnosis. Symptoms associated with DTC P2118 can greatly affect vehicle operation. A noticeable reduction in engine performance is common, as the throttle actuator may fail to respond adequately to driver input. This can lead to sluggish acceleration or difficulties maintaining speed, making the driving experience less than optimal. Increased fuel consumption can also occur, resulting from improper air-fuel mixture management due to throttle control issues. Drivers may experience an unresponsive throttle pedal, creating safety concerns during acceleration. Overall, these symptoms not only impair the drivability of the Honda Civic, but could also indicate potential safety hazards on the road, making prompt diagnosis and repair essential. The first step in troubleshooting DTC P2118 is to turn the ignition switch to the on position without starting the engine. Before diving into technical diagnostics, it's crucial to record all freeze-frame data and any onboard snapshot of the vehicle systems. This information will provide insights into the conditions under which the error was logged, aiding technicians in their analysis. Furthermore, reviewing general troubleshooting information related to this DTC will equip you with a comprehensive understanding of potential pitfalls and common repair techniques. This foundational step sets the stage for effective diagnosis and ensures that subsequent steps are grounded in accurate data. After turning the ignition to the on-to position, clear the DTC using the Honda Diagnostic System HDS tool. Clearing the code helps ensure that any transient errors that may not reflect current conditions are not mistaken for persistent issues. The next step involves slowly pressing the accelerator pedal to the floor, which allows the system to adapt and recalibrate the throttle actuator. Following this action, check for pending or confirmed DTCs using the HDS again. If DTC P2118 is still present, it indicates that the problem persists, thus necessitating further diagnostic steps. On the other hand, if no codes appear, it may suggest an intermittent issue, prompting a need for inspection of electrical connections to ensure reliability. Once it is confirmed that DTC P2118 persists, turn the ignition switch to the lock 0 position. This is a precautionary measure to ensure that all electrical systems are safely powered down during the diagnostic process. Proceed to jump the service check signal SCS line with the HDS, enabling secure access to the diagnostics for the electronic throttle control system. After that, disconnect the ECU, engine control unit, connector C, which typically consists of a 44-pin multi-connector. This connector is essential for the data and power supply to the ECM, thus facilitating accurate readings during further diagnostics. This step aims to prepare the engine control unit for resistance measurements, which will help in determining the integrity of the electrical pathways involved. In this step, measure the resistance between ECM connector terminals C3 and C4, which are crucial for the Electronic Throttle Control System Manager (ETCSM) circuits. The blue-red wire denotes the ETCSM positive line, while the green-yellow wire indicates the ETCSM negative line. It is crucial to find a resistance of approximately 1.0 ohm or less, as this indicates that the electrical pathways are intact. High resistance in these lines could signify a wiring issue, such as corrosion or breaks in the circuit. If the measured resistance is within this acceptable range, it suggests that the wiring is functioning properly, allowing you to proceed with further diagnostics. Conversely, higher resistance readings necessitate addressing wiring problems before moving forward. Upon confirming that the resistance between the ECM terminals is satisfactory, the next step is to disconnect the throttle body 6P connector. This connector is critical as it connects the throttle actuator to the electronic control system. With the throttle fully closed, measure the resistance between terminals number 5 and number 6 at the throttle body side, checking for a similar requirement of approximately 1.0 ohm or less. This measurement assesses the integrity of the electrical conduit leading to the throttle actuator itself. A reading of 1.0 ohm or less would suggest no issues within this circuit, while any higher resistance indicates a fault in the wiring that could lead to performance issues. This precise diagnosis is essential to ensure that the throttle actuator is receiving proper signals from the control system. If the resistance measurement in the previous step exceeds 1.0 ohm, it is important to repair any shorts in the wiring found between ECM C3 and C4, ETCSM plus and ETCSM minus lines. Here, meticulous attention is required to ensure that any breaks or shorts are thoroughly addressed, as these can severely impact throttle performance. Carefully inspect the wiring harness for any signs of damage, fraying, or loose connectors, as these can hinder proper electrical flow. Once the repairs are made, follow this up with continuity tests to confirm that the repairs have resolved the issue. After verifying the integrity of the connections and resolving any wiring issues, you can advance to the next diagnostic step to evaluate the throttle actuator itself. In cases where earlier diagnostics have confirmed no wiring issues, the final troubleshooting step involves replacing the throttle body. Given the component's responsibilities, if the actuator consistently fails to perform as expected, it strongly suggests that the throttle body may be faulty. Installation of a new throttle body should restore normal functionality, as it serves as a direct mechanism regulating air intake to the engine. After the replacement, conducting a functional test on both the throttle actuator and the ECM is crucial to verify their interaction and ensure they operate seamlessly. Complete the repair process by rechecking for any stored codes and performing a road test to confirm that the issue is fully resolved and that there are no remaining symptoms related to the DTC P2118. After completing all the necessary repairs and troubleshooting steps for DTC P2118, it is essential to carry out a final verification. First, confirm that the DTC has been reset and is no longer present in the system by using the HDS tool. Following that, conduct performance tests on the throttle actuator to ensure it responds accurately to inputs, demonstrating proper functionality. A road test is also recommended to confirm that the vehicle operates normally without any throttle hesitation or power loss during acceleration. Finally, revisit the system once more to check for any future DTCs that may indicate lingering issues. This thorough verification process ensures successful resolution and provides assurance of the repair's efficacy. Preventive maintenance is vital in ensuring that throttle-related issues, including those causing DTC P2118, do not reemerge. Regular inspections of the wiring harness, especially near the throttle actuator and ECM connectors, can help identify potential problems before they escalate. Checking for corrosion or other damage on connectors is crucial, as poor connections can lead to performance issues. Additionally, ensuring the throttle body remains clean and free of carbon buildup contributes to its optimal functioning. Implementing these preventive measures will not only prolong the life of the throttle actuator, but also enhance overall engine performance. By keeping a proactive approach, you can reduce incidents of related DTCs, ensuring the Honda Civic continues to operate efficiently. In conclusion, DTC P2118 signals a critical malfunction in the throttle actuator's performance and current range within the Honda Civic models 2006 to 2011. Understanding the role of the throttle actuator, the ECM, and the connections between these components is essential in diagnosing and resolving this error effectively. Following a systematic diagnostic process provides a clear pathway to identifying issues, whether they stem from electrical connection problems or faults within the throttle actuator itself. Implementing preventive measures is equally important, as it safeguards against future occurrences of similar DTCs. By doing so, you can ensure optimal vehicle performance and reliability, all while enhancing the driver experience in your Honda Civic. Please like and subscribe to the channel. See you next time.